All right, welcome to Chapter 5, Section 1, Solving Inequalities by Addition and Subtraction. This is for IM1 or Integrated Math 1. So as always, I'll just start off by going over this main screen. The first thing you should see on your student screen is the due date here before attempts. I just don't see it on the teacher preview. The second part here is the attempts. I'm on attempt number 1 of unlimited attempts. This means I can submit this assignment as many times as I would like. I can just keep coming back in and trying over and over again until I get the grade that I'm happy with there. Number of questions, this says it has 10 questions for this particular assignment. Just depends on the section that we're on. They'll have anywhere from 1 to 10 questions. Grading policy is best score. Whichever attempt is your best one is the one you get to keep. That's what that means. Partial credit is always enabled, which also, just has to do with if you answer 1 of 10 questions, you get credit for the 1 question. And we'll get to submitting here in just a second because there's some rules for submitting here. So if we read down below, it says, please remember, once you submit the homework, or once you start the homework, you must finish it before you can start, work on anything else. I'm not reading right off the screen there, paraphrasing a little bit there. So what that means is when I click the start button, I've started my homework. Now, no matter what, to leave the screen, in the bottom right corner, you on the student screen will see submit assignment. I don't see it on the teacher preview again, but you will see it on your screen. You always click that button when you're ready to leave. Even if you haven't started anything at all, or if you've only done 1 of 10 questions, it doesn't matter. You go ahead and you click that button. Number 1, it shows your teacher what you've been working on. It'll actually affect the grade book, things like that. And number 2, if you don't click the submit assignment button and you just close the screen or, close your computer down, whatever it is you do, the system is going to assume you want to leave this attempt open and it's going to lock you out of every other assignment. So click that submit assignment button. It saves your place wherever you are within the assignment. That's where you're going to start back up again. So you're not going to have to redo problems you've already done and received a check mark for, gotten them correct. If you've gotten them incorrect, yes, you get to do them again. Just to see if you can get the points for those ones. But so always click that submit assignment button. And on the side here, there's always these 3 tools. Sometimes there's also a calculator above. But we have explanation. It's telling me I'm going to lose my current question attempt because it's quite literally going to give me the solution to this question. So it's not going to give you the solution or the answer and then let you come type it in. But it's a very cool resource because sometimes you're stuck on just a specific problem, not the entire problem type. So you can see a solution to that one and then come back in and try again on another attempt. Example just opens up a general example, but it does give you, it's a very specific general example. So it's not just anything in particular for that type of topic. It's going to be something almost identical to what you're looking at. And then we have these pieces here. So we're looking at inequalities for this one, which we saw in the title, solving inequalities. So we have these pieces here. So over on the side we can have, this is less than, and then we have greater than, and we also have less than or equal to, which just has a equal sign underneath it. It's like half an equal sign. Or you have greater than or equal to, which has a line underneath it. And I'm going to be a little bit lazy on the video here and not write all of that out, but we will use both of those. So or all 4 of those. It just depends on what the question says. So like this one, it says 9 is less than or equal to. Okay, I hear the equal to, so that means I need to make sure I use the less than symbol with the line under it. So that my variable can be equal to 9, but it can be anything less than 9 also. So that's all that means. And I know my son laughs at me when I do this one, but I like to think of this. I know in school we learned like the alligator guy, like he eats the bigger numbers. But I actually really like Pac-Man. So I always make them little Pac-Mans just to kind of make that a little funnier. So that when we're doing that inequality, we can see it's always going toward the bigger number. We don't do that quite so much in IM1 anymore as far as, which number's bigger or smaller as far as the inequalities. We're going to be graphing them a little bit more. But we do have an answer down here below. And I'm a little picky. I'll explain why I'm a little bit more picky about this in a minute, about how we write these out. Okay, and then down below there's the message center, which will also, you can send a message straight to your teacher with this question attached so that we can see exactly where to help you. You can also click on example again and it'll give you another example. So that's definitely a very nice feature there. All right, so it says write an inequality for the following statement. A is greater than 7. So I come over here and I go A is greater than, so I know it's going to be this guy, and then 7. And I'm very picky about how you write this. I always say it should be variable, then an equality sign, then the number. And the reason is when we start to graph, as long as we have it in this order, it makes it very easy to graph, because this is almost like an arrow pointing in the direction that we're going to graph. But if we have it backwards like they did on the example where they had the number, the inequality sign, and then the variable, it doesn't work the same way. So I'm very picky about this. If you're doing this with me in class or on the videos here, I always want it in that correct order. So if it was written in the wrong order, say like this, if you notice this guy is pointing at the 7, right? Well, it's still pointing at the 7 if it's backwards. So when we want to flip it around, we just need to make sure that the inequality sign is always kind of pointing in at the same number. Or if it's pointing the variable, it's still pointing the variable when we flip it around. So if it was written backwards, we could simply flip it around to be the correct order. So, all right, let's go ahead and type this guy in. So it's A is greater than 7. Oop, and I hit S on the keyboard because I had my finger in the wrong spot there. You can also click on these guys. It'll throw the boxes in there for you and you can just fill them in. But I did that with my keyboard too. It's just right there above the space bar is my less than or greater than. Or right next to the keyboard, depending on which keyboard you're using. All right. So we're going to translate the sentence again. It's just a little bit bigger. So it says the product of B and 9. So product, that's one that I would definitely have a circle in class. Product of means multiplication. And product of also means it's going to be the multiplication of the next two pieces. So product of, I know immediately I'm going to have kind of a group. I don't really have to put the parentheses because it's a multiplication problem. But I know I'm going to be multiplying the next two pieces. So if it says sum of or difference of, those are ones that you definitely want to have some kind of parentheses around because you're going to be adding for sum, you're going to be subtracting for difference. But for these guys, if it's the product of 9 and B, well, that means 9 times B. And I know B came first, but it's proper to put the coefficient, the 9, before the variable. So instead of saying B9, we can say 9B. And is greater than or equal to. So it's greater than or equal to. We need to make sure we put that little sign there. And then 19. So with this one, I think they don't expect us to actually solve it yet. So we don't need to have B all by itself. We can actually just type this guy in just like that. I believe, oh no, it won't work on the keyboard commands. I have to click here. So on the keyboard commands, when you're on Google Docs or Word, you can actually do like a command and then the greater than sign, and it'll put the equal to underneath there for you. But on here, it doesn't recognize that command. So, all right, perfect. So for each value, V, determine whether it is a solution to V is greater than 7. Oh, let me grab my eraser real quick. So really quickly, what I'm going to do is I'm going to draw this number line where I have 0, and I want to focus on 7 for a moment. So I'm just going to place 7. It doesn't matter if I put all the numbers here. I'm just going to assume this is 7. And I want to look at numbers that are greater than or equal to this number. So they could be 7, and they can be anything greater than that number. And again, if we think about this greater than or equal to, it's pointing in the right direction. See how it almost looks like a greater than sign there? So that's very helpful if you just picture this is what I'm looking for. Any numbers that are 7 or bigger. That's what greater than or equal to means. So let's go ahead and start solving these guys. Just looking at this, if I have 8, well, 8's over here, so that works. So that would be a yes. 3 would be somewhere around here, so that doesn't work. 7 works because it is 7. So remember, it's greater than or equal to 7. So 7 is part of the solution there. And then 13, that would be somewhere over here, right, if I kept going. So that also works. So that'd be a yes. I have seen these be all yes. I have seen these be all no. So just make sure you're paying attention to the idea, is it greater than this number or is it less than this number? You know, what are they asking you to check? And a number line definitely just is a visual. It just helps us realize, you know, if I plot these points, does it fit in the category that I want it to fit in? All right, so let me get rid of this number line here because I don't think we need it. And if we need one, we'll draw another one. Okay, so write inequalities to represent the situations below. So we have the cargo of the truck weighs less than 3,000 pounds. Use W to represent the weight in pounds of the cargo. So the cargo of the truck weighs. All right, well, I'm going to do W for that because that's what they told me to do right here. And it's less than, so I know I'm going to use this guy, 3,000. So remember, less than 3,000 means that it can't be 3,000. It has to be anything less than 3,000. It could be 2,999.9999999. That actually still works because it's not 3,000. So we just can't have it be 3,000 or more. It has to be less than that amount. We can only have it be 3,000 if it said less than or equal to. But since we don't have that one, we just have to be very careful about how we're reading that. So W is less than 3,000. And sometimes it gives me grief about not putting the comma in. Sometimes it doesn't. It just kind of depends on the problem I think that we're looking at, or how the answers were written on there, if it's kind of a requirement. Abdul exercises no less than 50 minutes per day. And we're going to use T to represent Abdul's amount of exercise. So Abdul exercises, and they told us to use T for that, no less than 50. So no less than, and I think if we click on here, they actually give you another chart that includes this. So this should be on your notes page as well. I believe I included that little table on the notes page. So sometimes, instead of just saying less than, greater than, less than or equal to, greater than or equal to, they're going to use a little bit more words. So no less than is a greater than or equal to, meaning that we want it to be 50 or more. It's not going to be any less than 50, but it could be 50. So that's just one of those things we need to make sure we're paying attention to. And like I said, this chart should be on your notes. You should have your notes open right now if you're looking at this page and recording some notes on it. So this is no less than 50. So it could be 50, it could be 51, 52, anything above 50 or 50 or above, but it can't be less than that amount. All right, so T and greater than or equal to 50. Check. Perfect. Continue. Okay, so now we're going to get into graphing this guy. So again, as long as it's in this order, we have variable, inequality sign, number. And that's how I write it on the notes pages too. So I'm picky about that, like I said, because it helps us put this in the right order. I have X is greater than or equal to 9. As long as this is in the right order, I'm pointing in the correct direction. That's where I want to go. This equal to means it's going to include the 9. And the way we show that on the graph, including or not including, is open dot is not including. So this would be greater than or less than. A closed dot is equal to. So that means it includes the number. So that's how we actually visually show whether it's less than or greater than, or less than or equal to, or greater than or equal to. We just do an open dot or a closed dot. So on this one, we're going to click the dot we want. Since it's equal to, I'm going to click a solid dot. And then you can see the finger tool kind of pops up there with the dot. And I just need to go to the 9 and place my dot. Now I need to make sure that I click the line tool here, and it's going to either snap to one side or the other. So it's pointing in the correct direction. I'm going to go in the direction that my inequality sign is pointing. And like I said, this little arrow looks like a less than sign. So it can be 9 or anything smaller than 9. Any solution would work here as long as it's within that shading. And the shading goes on and on and on to the left forever unless there's some kind of limit to what it can be. All right. So with this one, it says solve the inequality for you and then simplify your answer as much as possible. So when we're solving an inequality, we actually solve it the exact same way we solve an equation with an equal sign. There are a few differences when we're doing this, and we'll get there. I believe it'll be in a couple more questions. The main difference is when we multiply or divide by a negative number. That has some kind of different effect on it. But other than that one rule that will make a different effect, everything else happens exactly the same way. We're trying to get u by itself, and I'll even change the color here just so it's a little dramatic on the picture here. So I'm trying to get u by itself. So I want to take everything away from u, or on the same side as u, I want to put it to the other side. And I do that with the opposite operations, just like I would with an equal sign. So 3 is being subtracted from u, so I'm going to add u to both sides. Sorry, I'm going to add 3 to both sides. I don't know why I said u. U drops down. Negative 3 plus 3, any number minus itself, cancels out. I had negative 3, I put 3 back, I have 0. Okay. All right, so now I have greater than or less than, that drops down, and then I have 11 plus 30, which is 14. So now I just come over here and I have variable, inequality sign, number. Now Alex will accept it the other way. If you wrote it 14 is less than or equal to u, because remember that inequality sign would flip with the 14 if we had it backwards. It'll accept it both ways. But again, I'm very picky about it. I want my students to get in the habit of always writing variable inequality sign number, because it makes it much easier when we're looking at the graph on how to read it. All right, so let's look at this guy. We have, and I'll switch back to red here for a minute, just write out the question. 6 is greater than or equal to 7 plus y. All right, so now again, we're trying to get this variable by itself. So 7 is being added, and make sure you're always looking in front of the number for if it's being added or subtracted. In this case, they're both positive, so it kind of looks like it, but this plus sign belongs to the y. We're just showing that it's a positive y in the equation, or in the inequality. So this is a positive 7, so I'm going to subtract 7 from both sides. This is not where that negative rule comes in. I'll talk about that when it comes in here. We're still just subtracting here. So 6 minus 7 is negative 1, because I subtract them. The bigger number tells me the sign. And I have greater than or equal to 7 minus 7 cancels, and I have y. So this is where I get picky and I say, switch these. I want you to flip-flop it so that y and negative 1 are on the other sides. Just make sure this guy is pointing at the y, so it should be pointing at the y when you flip-flop this around. It literally is like a mirror image. We just flipped it around, quite literally. So let me go y, and now it's less than or equal to negative 1. So it's easier to read that way because, again, we're going to read it from the variable anyway. So we don't want to have to try to read it backwards. And it just makes sure that when we do go to graph this, again, it's in the correct order, so I know exactly which direction to shade. All right, now we have some fractions here. So I'm going to clear this guy out real quick. We don't need all this other stuff here. Clear my paper. All right, so we have w plus 4/5 is less than or equal to 1/4. All right, so I want to, again, I'm still solving for this w. We could do this a couple of ways. We could actually multiply everything by the lowest common factor for 5 and 4 to eliminate fractions, or we could simply just deal with the fractions with subtraction here. It's kind of up to the student how you like to do that. If you were going to do the lowest common factor, which would be 20 for these guys, that's the lowest thing that both of these can turn into, you'd have to multiply everything by 20 to get to the same thing. So we'd end up with 20w. This guy would eliminate down to 16. This guy would eliminate down to 5. So we could do that. That's definitely an option if you've never seen that. So I could take this whole thing and go 20. I'm multiplying everything by 20. So w times 20 is 20w plus 5 divided by, or 20 divided by 5 is 4. So I have to note that there's something left over there. It doesn't just eliminate, but 20 divided by 5 is 4. and 20 divided by 4 is 5. So whatever's left over is now what I'm multiplying. That's why it eliminates the fraction. It eliminates the bottom by using the division, but something is left over here. So I end up with plus 16 is less than or equal to 5. And now I can just solve this just like I would any other type of problem. So this is definitely an option if you don't want to have to deal with the fractions. We can also, sorry, I get to click undo a bunch of times here, just deal with the fractions here and say, okay, I'm adding 4/5, so I'm going to subtract 4/5 from each side. And we're still going to have to deal with this 20 idea. 4/5 minus 4/5 cancels, even though they're fractions, they're still the same number. On this side, we have 1/4 minus 4/5. So in order to subtract these, I'm going to have to make them like denominators anyway. So I'm going to have to make them 20. So I'm still going to have to do that lowest common multiple of 20. To turn 4 into 20, I had to multiply by 5. So I'm going to multiply by 5 on the top. To turn 5 into 20, I had to multiply by 4. So I'm going to multiply by 4 on the top. So if you notice, I still ended up with 5 and 16. I still ended up with the same two numbers that I did that first time that I did this. I didn't end up with the 20 over here because the 20 is now on the bottom of the fraction. So I still end up with the same three numbers that I did the first time. It's just a different kind of way of doing that. Totally depends on your preference there, how you want to do that. So 5 minus 16 is 11 over 20, which again, that's exactly what we would have ended up with if we had done the same thing on the other side there. We would have had 5 on this side, we would have subtracted 16, gotten to the 11, and then to get W by itself, we would have divided by the 20. So we still would have ended up with 11 over 20. It doesn't matter which way we do that. We still end up with the exact same answer. So just some students really don't like to deal with those fractions within the problem. So they like to try to eliminate them, but it's really not eliminating any steps. It's just a different order of steps. So, all right, let's go ahead and check that guy. Uh-oh. Oh, did I forget the negative? I forgot the negative, darn it. That's what I forgot. And I even forgot to put that over here. It would have been negative 11 because 5 minus 16 is negative 11. All right, recheck. Perfect. I got a little bit too into explaining the fractions there. Forgot to do that part. Okay, so now we're going to do decimals. So I don't think we're going to get into the multiplication division. This one is called addition subtraction. So we're probably going to get into multiplication and division on the next section. So I'll explain that step when we get there. That's why we haven't dealt with that. I mentioned it and then we just kind of dropped it and I haven't picked it back up because it hasn't happened again, or it hasn't happened yet. All right, so we have fractions here, or not fractions, we have decimals. I want to get x by itself, so I'm going to do the same thing I normally would do. 6.9 is being added. I'm going to subtract 6.9 from both sides. These are both negative, so I'm going to add them together and keep the negative sign. I had negative 2.4 and I'm going 6.9 more negative. So it's moving more to the left if we think about a number line there. And this is less than, x is going to drop down here. 6.9 minus 6.9 cancels out. So again, I'm going to flip-flop these because I'm very picky about that. And I'm going to have these written the other way. And this is open toward the x, so it should be open toward the x, or it's pointing at the 9.3, so it should still be pointing at the 9.3. All right. So we have x is greater than or equal to negative 9.3. And we can check that guy. All right, we have one more of these guys. Okay, so we have Rita buys candy that costs $5 per pound. She will spend more than $40 on candy. What are the possible numbers of pounds she will buy? And then it tells us to use P for the number of pounds Rita will buy and write your answer as an inequality solved for P. So they actually want us to solve and figure out exactly, you know, how many pounds she could buy in this case. Remember, it's an inequality, so it's not going to equal a number. It's going to be greater than or less than a certain number, depending on our problem here. So we want to always think about the word problem. What are we being told? it doesn't specifically matter who it is or what they're buying. We know they're buying something in this case. And yes, it's very specific. It's Rita and she's buying candy, but the name of the person and the item they're buying isn't terribly important. But the fact that they're buying something and it costs something either per item or per pound, that's important. So the candy costs $5 per pound. That's definitely an important piece. We want to remember that. Also, the total. Sometimes they'll give you the total. Sometimes they'll give you kind of a starting point. It kind of depends on the problem there. In this case, it's telling us she will spend more than $40 on candy. It's not no less than 40. That's where we would do the greater than or equal to. This is more than 40. So it's not going to be 40. It's going to be more than 40. So we want to make sure that it's greater than $40. Right? More than 40. So now we want to change this up because we don't want this per pound. So they told us to use P for the number of pounds. So per means multiplication and P for pound. So we have 5P, we don't need to put the dot, is greater than 40. So now I want to solve it because they told me to solve it for P. I'm going to divide both sides by 5 because it's being multiplied by 5. And I'm going to have 5 divided by 5 is 1. And that's going to be greater than 8. So she has to, it's anything greater than 8. So not 8 pounds. That would mean she spent $40. It says she spent more than $40. So we don't want it to be 8. We want it to be more than 8. So P is greater than 8. Alrighty, so that was section 1, and I will see you in section 2.